Ooh, alternating series test. That might help me talk about that problem I skipped at the end of the last video. What is an alternating series? Give me examples. So, the example from the previous video was negative 1 to the n over the cube root of n. That one was an alternating series. So, an alternating series, it just looks like we bounce. Negative, negative, positive, negative, positive. So, we could look like that. Theoretically, you have cosine or sine in there, because if you do like cosine n pi, is that right? Yes, cosine n pi, then that will bounce between 1 and negative 1. So alternating series will bounce back and forth and back and forth and back and forth. Think of what's going on and determine whether we converge or not. All right. This one diverges. This one diverges. How do I know? Well, this one, think of the divergence test. What's the limit as n goes to infinity? Ignore the negative 1. N over 3n minus 1, that goes to 1/3. So since that limit is 1/3, then we diverge. That fails the divergence test. Diverge. This one, sine pi x over 2. Well, that should be pi n over 2, first of all. But when n is 1, that's sine of pi over 2, which is 1. When n is 2, that's the sine of pi, which is 0. When n is 3, that's 3 pi over 2, which is negative 1, 0, 1. So this isn't going to settle on anything. So that diverges. Again, the limit of that one is not 0. So the divergence test says diverge. Let's see. This one. That looks like 1 over n with a 3 there, which would diverge. But with that alternator, so the problem with 1 over n is we don't get to 0 fast enough. But with the alternator, we take what was kind of positive values and going like this, and we throw in some negative pieces. So that one would be negative, and that one would be negative. And I think that might drag me close enough so that I think that might be 0. Or not 0, but I think that might go to 0 fast enough is what I mean. This one looks like 1 over n, but is even bigger. But again, I'm wondering if that alternator helps me. Well, let's consider the limit. The limit as n goes to infinity, the natural log of n plus 1 over n. Top goes to infinity, bottom goes to infinity, so let's go ahead and L'Hopital that. Derivative of the natural log is 1 over n plus 1. Derivative of n is 1, so that goes to 0. So that's going to 0. And the question is, do we go fast enough? I'm going to guess, because we have that alternate piece, that we do go fast enough. 1 over 2n factorial would converge. I think I could do it using the ratio test. So putting that alternator in wouldn't change that convergence. If anything, it would make it converge faster. Cosine n pi is an alternator. 1 over n squared already converges by the p-series test. And so if I add a negative 1, that's just going to make things go faster to 0, so that will converge faster. That's my conjecture. Let's see what's going on. So my argument is, if an limit as n, write it correctly, if the limit as n goes to infinity of an is 0, then the summation of an converges. That's essentially what the alternating series test says. If the limit of the sequence is 0, then the series will converge because we are alternating. If we're not alternating, then we will not necessarily converge. That's essentially what the alternating series test says. If you'd like to know exactly what your book says, A, look in your book. B, it says AK is a sequence of positive numbers. If ak plus 1 is less than ak, so we're getting smaller, and the limit of ak equals 0, then the alternating series converges. So essentially the only tweak they added into that is I need to be decreasing. Okay. All right, now as I look at this page, if we were in class, we'd play with a bunch of different things, but here's what I'm going to tell you. Again, that one diverges, that one diverges. Let's take a look at this one here. If I wanted to know how much, say, my fifth partial sum, how like close that would be. So that would be taking the first 5 terms. Okay, so when n is 1, that's -1 squared, which is 1. And then 3 minus 1 is 2, so that's a half. And then minus 3 times 2 is 6, minus 1 is a fifth. And then 3 times 3 is 9, minus 1 is 8. Oh, so they're all going up by 3, so I can do that. 1, 2, 3, 4, and 5. So if I went to my calculator here and added those, plus an 8th minus an 11th, if I could press the buttons correctly, and then plus a 14th. And I have 0.4055 and some other digits. If I wanted to know how close that was to the actual answer, I wouldn't really know, because I don't know what the whole sum is. And I could go on an exploration of geometric series and show you some, I don't want it. So here's what I want to tell you. That sum is no more, S5 is no more, actually, I guess I'll do this as this. The whole sum minus the partial sum minus S5 is less than the first thing I don't pay attention to, so 1/17, because that's the next term. The next term there is going to determine how much we're off, because if we think about it, we had a half, and then a fifth, and then an 8th, and then an 11th, and so we're getting closer and closer and closer to the x-axis. And we're no more than this far away. Our next piece, we're no more than that far away from the real answer. I hope that makes sense in your brain a little bit. If you think about that visually, that maybe helps. If you want a more concrete thing to explore, try this. We know that this sum will converge. In fact, we know it will converge to the first term over 1 minus the common ratio, which is 1/4 over 3/4, which is 1/3. The second partial sum would be 1/4 plus 1/16. And let's go decimals, because that might be easier for you to see what's going on. So that's 1/4 plus 1/16. Oh, I suppose I should do an alternating one, huh? I'll make that alternating. One moment. Make that a negative. Make that a minus. Make this a negative. So make this 5/4, and then 1/5. So 1/4 minus 1/16, that's a plus, so a minus, is 0.1875. 1/5 is 0.2. The first thing we didn't pay attention to would be 1/4 cubed, which is 1/64. Now 1/64 as a decimal is 0.0156. 0.0156. These are that are less than that far apart. If I subtracted 1.1875 from 0.2, I'd get less than that number. And that's how we find the alternating series error. The alternating series error simply has to do with how big your next term is. How big is the first term we don't pay attention to? Our error is less than that number. All right, now I really like this topic because it's really not that scary. What do you think it means for a series to converge? Absolutely converge conditionally. I'm going to give you two series. They're both going to be alternating series. And I didn't have to split those. I could have put that as negative 1/2 to the n if I wanted to. And here. You should take a minute, you should pause, and you should determine how these things converge. You should figure out what test to use and all that jazz. I'm going to do it in a minute, not a minute, like 10 seconds. So make sure you do the thinking right now. Have you done the thinking? I hope so. Because here's the deal. This one converges by the geometric series test. This one, in fact, converges absolutely. Because if that was 1/2 to the n, it's fine. Doesn't matter that it's negative 1/2. For this next one, this one converges by the alternating series test. Alternating series test. But this one converges conditionally. Because if I ignore that negative 1 to the n, then I have 1/n, and 1/n does not converge. That's the harmonic. We do not converge. So we have to have the negative 1/n, negative 1 to the n, there in order for us to converge. So that's the conditionally part. The conditionally part says I need the negative 1 alternator in order to converge. If I don't have that, then I do not converge. Maybe another example would be, get rid of this reason because I'm going to change this. If I had this one, that converges absolutely, because if I take the absolute value of the sequence, then 1/n squared still converges by the p-series test. I hope that's a little clear. Ask questions about that if you are confused. This one I'm going to leave up for you to decide and bring questions to class. And the same thing here. Your turn to do the ratio test. I will give you this one hint. I'll write down what an plus 1 is. N plus 1 plus 2, so n plus 3. Come with questions.